Hi everyone, wishing you all a very good afternoon. I hope all of you are safe, healthy, and happy as always. Am I audible and visible to all of you? Good afternoon, Yarika. I hope everything is fine at your end. Good afternoon, Abhiram. How are you? Well, as always, let us start today's class. Good afternoon, Tarun. Let us start today's class with the same old instructions. And what are those instructions? Keep your mobile cameras off. Sit in a place where you get good network. Do not move around while you are taking the class because the network might go and come. So you would get disconnected from the class. Anything that you want to ask, you can always send a message at the ID of Astik, or you can address it to everyone. Moreover, I am also allowing you to unmute yourself. Though I had a bad experience in the previous class, someone came and started talking nonsense, but still, I hope that he will not be disturbing us in this class. So you can unmute yourself when I ask you to do it, and we can discuss the class, discuss the question. Can you remind me what we were doing in the last class? What was the topic of discussion in the last class? Did I give you a question, something of that nature? Let me check. If I'd given you some question, what was the last thing that we did in the last class? Anyone can recollect that? What we had done in the last class? No one remembers it? Mhm. What was the point of discussion in the last class? We are obviously discussing relative motion in two dimension beta. Yeah, that is what I know. And where we doing some problems? We had seen some formulas of relative motion in two dimension, and we had done a problem where we had found out the velocity of A with respect to B and B with respect to A. So I'll just continue with the same question. Not with the same question, I've just changed the question a bit. So we'll start with this question. As you can see, what I'm drawing here is north, south, east, west, north, south, east, and west. So the question is like this: a car A is moving towards north with a velocity 3 meter per second. Car B is moving towards west. I'm not drawing it so that you have to draw it. Moving towards west with a velocity of 4 meter per second. To find the velocity of A with respect to B and velocity of B with respect to A. Can you do that for me? All of you? It's pretty damn simple. I hope you remember the use of I and J. I is the unit vector along positive x-axis. J is the unit vector along positive y-axis. Minus I along minus x and minus J along minus y. Your time starts now. Your time starts now. Are you trying the question? Who is trying this question? Anyone getting anywhere near answer? Anyone would help me? Anyone could give me a hint? Niharika has come up with the first answer, 3j plus 4i. Niharika, whenever you talk about vectors, you write vectors, you always say the x component first, I wala component first, and then you say j wala component. Always remember that. Now Niharika has corrected her answer. And that is the correct answer. Niharika, can you unmute yourself and tell me how you have done this?
Sir, can you hear me?
Yes, beta, tell me.
Sir, we need to find the velocity of A with respect to B.
We have to find the velocity of A with respect to B. That is correct. How are we supposed to do this?
Sir, it is the velocity of A with respect to ground minus velocity of B with respect to ground.
Velocity of A with respect to ground minus velocity of B with respect to ground. So the only thing now remains is to find our velocity of A with respect to ground. How do we do this?
Sir, already it's given in the question.
What is given in the question?
Velocity regarding to the north and velocity in the westward direction.
So velocity of A is 3 meter per second like this. And velocity of B is 4 meter per second like this. Am I correct, Niharika?
Yes, sir.
Okay, and we must also know that we have vectors in this direction. We have I vector here, we have j vector here, we have minus I vector here, and we have minus j vector here. Am I correct, Niharika?
Yes, sir.
Okay. Now tell me, how do I find the value of velocity of A with respect to ground? How much is the velocity of A with respect to ground?
Sir, it's plus 3j.
Plus 3j, because it is 3 meter per second along positive j. So it is plus 3j. Okay. Minus of what?
Minus of 4i.
Minus of 4i, because it is 4 along minus I. So it is minus 4i. So what do I get from here?
Sir, it's 3j plus 4i.
It's better to write it in this fashion. 4i plus 3j. Well done, Niharika. Can I have raised hands from everyone that we have understood what we have done here, what Niharika has told us to do? She has told us to find out the velocity of A with respect to B, and we have found it out. Abhiram has understood this. What about others? Shrirata, Bhojraju, Vasant, Tarun, Tanu, Nayan, Vishal, Akshay. We're all there. We are understanding it, right? Tanu, do you understand this, beta? Okay. But Niharika, I must add here that I would also like you to find out what is the magnitude of velocity and what is the direction of velocity. What do you think is the magnitude, Niharika? You can unmute yourself. Velocity of A with respect to B, the magnitude. How do you find it out?
Sure, it's the under square root of x square plus y square.
Under root of x square plus y square. What is x squared here? What is x here?
Sure, it's 4 square.
4 square. What is y here? Y is 3. So y square is 3 square. When you do it, you will get 5. Do we all agree on this, that we will get 5 meter per second when we do x squared plus y squared? Okay, that also takes me to the last part. I have to find that the angle it makes with the x-axis. How much is the angle it makes with the x-axis? To find the angle it makes with the x-axis, I must divide y component by x component. How much is the y component? And how much is the x component? Niharika, the y component is 3 and the x component is 4. Tan theta with the x-axis is 3 by 4. You know, this implies that theta with the x-axis is 37 degree. Do we all agree on this, that we can find out the value of theta? Theta will come as 37 degrees. Can I have some raised hand that we understood this up till now, up till at this point? We have found out that this theta is 37 degrees. The angle that this velocity makes with the x-axis is 37 degrees. Srilata, Bhojraju, Surya, Vasant, Tarun, Tanu, Nayan, Vishal, Akshay. Tan of 37 degrees is 3 by 4. So if tan theta is 3 by 4, theta must be 37 degrees. In which quadrant is this 37 degrees coming? So you can see x is positive and y is also positive. So which quadrant, Niharika? Tanu, Tanu, Tarun, which quadrant this is coming? This would come in the first quadrant. Yes or no? Now, see, it's always very easy, Tanu, to get an answer. I'm not very happy if you get the correct answer. I'm more happy when you understand what you have gotten, what you have achieved. Now, see, this was a diagram. A was moving like this. B was moving like this. Now, when I found out the velocity of A with respect to B, please mind my words, I found out how A looks to B. That means if I become B and I watch A, how is the motion of A looking like? What do I see? I see that the velocity is, the magnitude is 5 meter per second, and it makes an angle of 37 degrees with the x-axis in the first quadrant. Now I will try to draw it. First quadrant, this is my first quadrant. This is the velocity of A with respect to B. This angle is 37. And this length, the magnitude of this vector is 5 meters. So when you become B, this is how A looks like to you. When you are on ground, A is moving northwards and B is moving westwards. That is what you see. But when you become B and you look at A is moving like this at an angle of 37 degrees. Difficult to imagine, I guess, but this is absolutely correct. Physics is telling us something. There must be no doubt on its authenticity. It must be correct. Am I clear with this concept of how B looks and how he finds A moving as? Can I have some reason that we have understood this? No one understands this? Abhiram seems to have understood this. Tarun also, Niharika also, Vasant also. What about the others? Nayan, Tarun, Tanu, Srilata. Tanu also seems to have been there. Akshay, Vishal, Nayan, I think they are not able to respond. Okay. Now comes the next question. And if you are attentive enough, without even solving it, you should be able to tell me the value of velocity of B with respect to A. Can anyone tell me without solving anything? Once you have solved Once you have found out the value of velocity of A with respect to B, can anyone tell me what will be the velocity of B with respect to A? I'll lower all hands. Who can tell me the velocity of B with respect to A without solving anything? Niharika obviously knows it, but I would like someone else to give the answer this time. Niharika knows it. Niharika has already given the answer. What about the others? Can anyone else tell me what will be velocity of B with respect to A? Knowing the velocity of A with respect to B. Abhiram, Vishal, Nayan, Tanu, Tarun, Vashant, Surya. Anyone can tell me what will be the velocity of B with respect to A if I already know the velocity of A with respect to B? Anyone? Open challenge, open question. I'm waiting. Abhiram has come up with an answer. Abhiram, there is something wrong in your answer. Can you again check it? Again check it. Velocity of B with respect to A. Knowing the velocity of A with respect to B. Does anyone remember the relation between velocity of A with respect to B and velocity of B with respect to A? Does anyone remember that relation? Velocity of A with respect to B is equal to negative of velocity of B with respect to A. Do we remember this? They are opposite of each other. Yes, Abhiram, now you are correct. So now, Abhiram, can you unmute yourself and tell me how you have done this? Abhiram, it seems, can't unmute himself. Niharika, your turn now. Tell me how to do it.
Sir, we need to find the velocity of B with respect to A.
Yes.
Its velocity of B with respect to ground minus velocity of A with respect to ground.
So you can do it in this way. Velocity of B with respect to ground minus velocity of A with respect to ground. You don't have to do this much. You can straight away get your answer from this equation, right?
Yes, sir.
So what will be the velocity of B with respect to A? It will be negative of what we have got in the first case. Negative means it will be minus 4I minus 3J. Am I correct, Niharika?
Yes, sir.
So you find it out from the original formula or you find it out from this formula. In all cases, it will come same. What about the magnitude of velocity of B with respect to A? What is the magnitude, Niharika?
Sir, it's 5 meter per second.
Under root of again 4 squared plus 3 squared is again 5. What about the angle it makes with the x-axis, Niharika? Tan theta.
It's 37 degrees, sir.
So tan theta would be Vy, velocity y along velocity x. It will be 3 divided by 4. I don't divide minus 3 by minus 4. I always divide 3 by 4. That implies theta with the x-axis will be 37 degrees. Now you tell me which quadrant it lies, Niharika.
Sir, it lies in third quadrant.
X is negative, minus 4I. Y is negative, minus 3J. So it must lie in the third quadrant. And now is the time that I draw it, and you see, I can just draw it like this. Velocity of B with respect to A. And as you can see, this direction and this direction, they are opposite. This angle is 37 and this length is 5. Are we getting the concept? of velocity of A with respect to B and velocity of B with respect to A clear in our heads, everyone? Do we all understand this? Anyone has any doubts on this question, about this question? Anyone? Please raise your doubts now. Is there any doubt anyone has? Can I have some raised hand that we have understood this, sir? No one has understood this? Apart from Niharika, Srilata, Bhojraju, Surya, Vasant, Tanu, Vishal, Akshay. Have we understood this, beta? How we have done this? Okay, fine, great. Now, what we'll do is, we'll try to attempt a problem from your notes. You're going to attempt a problem from your notes, and this problem is, I think, problem number 10, I think. Let me see. Problem is coming right now. Problem number 12 is what we are going to solve, and the problem comes now. Let me make it bigger. An old man and a boy are moving towards each other, and the bird is flying over them as shown in the figure. The bird is flying over them as shown in the figure. You can see the tree. Here is the tree. This is the tree. Obviously, tree that rests with respect to ground. There is a boy running with respect to ground, 16 meters per second. Old person in blue, moving with a velocity of 2 meters per second in the backward direction. There is a bird which is moving with a velocity of 20 meters per second at an angle of 37 degrees. So these are the three things given to you. What are you asked? Find the velocity of tree, bird, and old man as seen by boy. That is question number 1. Find the velocity of tree, bird, and boy as seen by old man. Find the velocity of tree, boy, and old man as seen by bird. So basically, there are 3 people here: boy, old man, and bird. We are supposed to find out the velocities of everything with respect to every other thing. We'll do part 1 of this question. Part 1 of this question is, find the velocity of tree, bird, and old man as seen by boy. We'll be doing this part in the class now, and the other 2 parts will be given to you as homework. I hope that you do that homework. We'll do part number 1 now. Your time starts now. Tree is given, boy is given, old man is given, bird is given. You have to find the velocities of all these people, 3 people, with respect to boy. Velocity of tree with respect to boy, velocity of old person with respect to boy, and the velocity of bird with respect to boy. Your time begins now. I hope you are trying the question. There is a man, there is a bird, there is a person, there is a tree which is stationary. You have to find the velocities of everyone with respect to the boy. Question number 12. I will draw a short diagram here. Let me see how much space I have. Okay, I think this is good. This is my ground. This is my tree, my boy, two eyes. Velocity of boy VB is 16. Old man, two hands, two eyes. Velocity of man is 2 meter per second, like this. Then there is a bird here. Velocity of bird, let me call it VD, is 20. And this angle is 37. You are supposed to find out velocity of, okay, here's the tree also, tree. To find out velocity of tree with respect to boy, velocity of man with respect to boy, and velocity of bird with respect to boy. Your time has already started. Anyone with an answer? I would be pretty damn pleased. Let's see who does it for me. Niharika has already come up with an answer, Niharika. Well done, beta. Well done. You have come up with the answer. That is correct as well. Okay. What about the others? Let us give some time to everyone to solve the question. Else, I will ask Niharika to solve it. She has already solved one part. What about the others? Abhiram, Tanu, Vasant, Tarun. Are we solving the question, beta? Do you want any hint? Please let me know. I'm here to help you. In my case, all of you are equal, whether it's Niharika. Niharika might be solving a lot of problems, but that doesn't mean that Niharika has given the second answer as well. That is correct, Niharika. Minus 89. I think that is correct. Good one. I value each and every opinion in the same way as I value Niharika's or Abhiram's or anyone else's opinion. All opinion are same. Doesn't matter who is giving me that opinion. So anyone who solves it, even if you don't solve it, you try it. I would be very glad. Even if you don't try it, if you are thinking about the problem, that is a start. Anything that you do, I would appreciate it. If you are even attentive in the class and coming to class regularly, even that is a big thing. Sir, what is the third question? Velocity of bird with respect to boy, Niharika. That is the third question. Velocity of bird with respect to the boy. Anyone? I'm still waiting. Anyone needs any help, please let me know. I would be very glad to help you out. Okay, let me ask you some question. Abhiram, are you trying the question? Have you got any answer? Vishal, Tanu. Okay, so let us now try to solve this question. Niharika, can you unmute yourself and help me? How are we going to do this?
So first we need to find the velocity of tree with respect to boy.
Yeah, so first of all, let us find out, Niharika, velocity of everyone with respect to ground. Okay. So let us start with velocity of t with respect to ground. What is that? How much is that?
Sir, it's 0.
Is zero. Well done. It is zero. Next. Why did I do this? It is zero. We all understand this, I guess. Let us go on to the second step. Find the velocity of boy with respect to ground. How much is that, Niharika?
Sir, it's plus 16.
Plus 16. Remember, beta, this is motion in two dimensions. This is motion in two dimensions. So I have motion happening along x-axis as well as motion happening along y-axis. So if you say plus, it will confuse me. So instead of saying plus, you always try to say in terms of I, j, minus I and minus j. Am I clear, Niharika? How do I do it?
Yes, sir.
Now look at boy. Boy is running like this. So how will I say its velocity? Velocity of boy with respect to ground will be how much? Niharika?
Plus 16i.
Plus 16i. I hope everyone is understanding this. Can I have some raise hand that we have understood this? Plus 16i. It is 16 meter per second like this along positive x. Up till now, we were calling it plus 16 and minus 16, but here motion is happening here and there, and x-axis and y-axis are taken together. Therefore, you are writing it as plus 16i. Can I have some raised hands on this? Can I have some raised hand on this? Great. Okay. What next? Niharika, what will I do next?
So we need to find the velocity of man with respect to ground.
Velocity of man with respect to ground. Look at the man. This is the man. I mean, this is the man moving like this. How will I write it in vector form, Niharika?
Minus 2i.
Minus 2i. Can you explain why it is minus 2i?
So because it is in the direction of negative x-axis.
It is in the direction of negative x-axis. The magnitude is 2. So I write it minus 2i. Well done, Niharika. That is good. Now comes the toughest part. Why I call it toughest? Because we have already done it, but we had done it some 3, 4, some 2 months back. Human beings, we always have a loss of memory. I have short-term memory loss. I lose things very easily. But most of us, if you have done something 1 or 2 months before, the memory will start fading. Let us see how sharp is your memory. How much do you remember? Now look at bird. Look at this gentleman bird. The bird is moving like this. I call the velocity of bird. This is with respect to ground. This is 20 meter per second like this. And this angle is given as 37 degrees. Now, if you want to write it in vector form, you will have to break it up into x and y component. This component will be known as the x component, and this component will be known as the y component. What has happened? Am I correct, Niharika? I have to find the x and the y component. Yes or no? I have to find the velocity ka x component and velocity ka y component. Yes. Now, how will I find the velocity ka x component? This is 20 and this is 37. So this will become 20 cos 37. Do we remember how did we resolve vectors into components? This is the vector. This angle is theta. So this side becomes v cos theta and this side becomes v sin theta. Do we remember this? Horizontal and vertical. Do we remember this? Please raise hands if you remember. Please raise hands if you remember. Yes. So 20 cos 37. Cos 37 is 4 by 5. So this becomes 16. The x component becomes 16. Now, what is the y component? If the x component is cos 37, the y component has to be sine of 37. How much is sine of 37? It is 3 by 5. So 20 multiplied by 3 by 5, and we get this as 12. Do we understand this? Vy is 12 and Vx is 16. Can I have some reason that we have understood this? Yes. But we had to write it in a vector form. Velocity of bird, oh, I cannot write B, I will just write it as D. Velocity of bird with respect to ground is how much? It has two components, x and y. This one is x and it is going like this. This one is y and it is going like this. Can anyone tell me how will I write in vector form? 16 is along positive x, so Niharika, it becomes 16i. 12 is along positive y, it becomes 12G. Do we all agree on this? Can I have some raised hands on this? This is the most important aspect of this question, finding the value of the velocity of bird with respect to ground. That is the only difficult part in this question. Everyone got this? Can I have some raised hands, so we understand this? Not a problem. It's pretty damn simple. Tanu has raised her hand. What about the others? Abhiram also is there. Niharika is there. Vishal, Akshay. Akshay is. Akshay, you want to speak something? Your mic is on. Nayan, Srilata, are we all there? You all understand? Great, great, great. Good one. But see, we have done so much, but still we are nowhere. We have not solved the question. Now is the time that we start solving the problem. And the first problem was velocity of t with respect to b. Who is going to tell me what is the velocity of tree with respect to boy? That was the first part. Velocity of tree with respect to boy. How will I find it out? Anyone? How will I find out velocity of tree with respect to boy? How will I find it out? Tanu, can you give the answer, beta? You raise hand. Can you give the answer? Unmute yourself. Give the answer. Abhiram has raised hand, so I'll give Abhiram the chance. Abhiram, unmute yourself. Tell me the answer. Probably Abhiram can't unmute himself. Anyone else would like to do this problem? I raised it by mistake, not about Niharika. Chalo, Niharika will do it for us. Niharika, tell me how to do it.
So velocity of tree with respect to boy equals to velocity of tree with respect to ground minus velocity of boy with respect to ground.
The velocity of tree with respect to boy, we are using the same formula, will be equal to velocity of tree with respect to ground minus velocity of boy with respect to ground. Tell me what are the values?
So it's 0 minus 69.
0 minus 69. 0 is the velocity of tree with respect to ground. It does not move. Minus 69 is the velocity of boy with respect to ground. It does move. Not minus 69, it is plus 69, but minus comes from the formula. So the final answer is minus 69. Minus 69 is the velocity of tree with respect to boy. Am I clear with this one? Okay. Next one. What is the next one? Velocity of old man with respect to boy. Niharika, continue.
So velocity of man with respect to boy equals to velocity of man with respect to ground minus velocity of boy with respect to ground.
So you have to find the velocity of man with respect to boy. How are we going to do this? We are going to find the velocity of man with respect to ground and subtract the velocity of boy with respect to ground. Niharika, tell me the values.
So it's minus 2i minus of plus 16
Minus
I
2i is the velocity of
mi-
man with respect to ground. Minus plus 16i is the velocity of boy with respect to ground. Once we solve it, we get the value as minus 18i. Right? That takes us and that brings us, that gets us to the last part of this question, which seems to be the most important and the most difficult one. It is not so difficult if you just apply simple physics. What is the last part? Velocity of bird with respect to boy. Niharika, can you tell me that?
so it's velocity of bird with respect to ground minus velocity of boy with respect to ground.
It is definitely velocity of bird with respect to ground minus the velocity of boy with respect to ground. Can I have the values?
So it's 69 plus 12j minus plus 16j.
16i
16i
plus 12j. That is the velocity of bird with respect to ground minus plus 16i, which is the velocity of boy with respect to ground. And what do I have at the end of the day?
plus 12j.
Plus 12j. A very important aspect. When the boy, see, where is the boy? Where is my boy? When this boy looks at the bird, even though the bird is moving in this direction with respect to ground, to him, it is not in that direction. To him, it is just going vertically upwards, like this. He only sees his vertical motion. This horizontal motion for him has disappeared. Why it has disappeared? Niharika, Abhiram, Tanu, Tarun, Prashant. Why? He does not see any horizontal motion. Why he only sees vertical motion? Can anyone tell me? Why he only sees vertical motion? Why he does not see the horizontal motion? Where does the horizontal motion go? As you can see here, this 16i, which is the horizontal velocity of bird, is cancelling out with 16i, which is the horizontal velocity of this boy. So both are having the same velocity in the x-axis, and therefore along x-axis, this boy does not see the bird moving. Am I clear? Both have same velocities along x-axis, so this boy does not see the bird moving because they are moving with the same velocity. Am I clear with my explanation? Can I have some raised hand that we have understood this, sir? The boy only sees the bird going up and does not see his horizontal motion. Anyone has any doubts? Can I have your raise hands that we have understood the question? No one has understood the question. Abhiram seems to have understood. Tarun seems to have understood. What about Vasant also? Okay. Tanu, Vishal, Nayan, Bhojaju, Shilata. Are you there? You understand the question? Great. So now the rest of the two questions, the rest of the two parts of this question will be given to you as an exercise. So what I'll do is I'll give you those parts as an exercise for homework that you have to solve at home. Can you do that for me, everyone? Can you do the two parts at home? Yes, we have done almost the entire question. We have done almost the entire question there. We have found out the velocity of tree with respect to ground. We have found out the velocity of man with respect to ground, boy with respect to ground, and bird with respect to ground. Now, in the other two parts, you are supposed to find out the velocity of the other three with respect to bird and the other three with respect to the old man. I hope you can deal with that question. Put your answers in the group. Learning, as I always say, is a team sport. Learn together, flourish together. Now, that takes us to another set of important topic in this relative motion, which many students find very difficult. And as soon as this topic comes, they start to disappear. That is known as relative motion in river flow. What is this relative motion in river flow? Anything different? No, it's nothing different. Same old story, same everything. Now, what type of problems are we going to encounter? Now, instead of buses and cars moving on road, now road is at rest with respect to earth. Road does not move with respect to earth. So the question is still looks simpler. But when the question is shifted from road into a river, now it's very hard to see river these days. In wherever part of world or India you live, all these rivers have been stopped and dams been built. You don't actually see a river and you don't actually see any flow, because wherever you see you will see dams and everything getting stopped, and that is why you get floods. There were floods in China, there were floods in India. It's all man-made. Anyways, river is flowing. River flows from Himalayas in our case, and they fall into they are supposed to fall into the ocean. Whether they do it or not, it's a different issue. River flow. Now, when river flows, water is flowing into it. And now, the sort of questions that we'll encounter will have either a man or a swimmer or a person trying to swim or a boat which is moving on the river. We'll have to solve questions in that category. Now, when the river question comes, river is also flowing. So there will be 2 or 3 things that will be common to all the questions that we solve in river flow. Basically, we'll solve questions on river flow in 1D, one dimension, and the more difficult ones will be in 2D, two dimension. Now, whatever be the problem in this relative motion in a river, whether it's problem of 1D or is a problem of 2D. All the problems are based on this one formula. The question is, do we know this formula? When the answer is yes, we know this formula. So we already know this everything. And as I always say, my dear students, I have told you everything that you are supposed to know. Now I'm just going to tell you how you are going to apply the application. And that is the most difficult part in physics. That is what makes physics confusing. Sir, I know to everything, but I can't apply it. That is where teachers come in. They teach you or they guide you in applying those concepts. Now, before going on to applying these concepts, we must understand here what you would be given in the question. What sort of terms will come in this question? For example, when you had a horizontal projectile, a question, we had a plane flying, the plane was flying with some velocity and it was dropping bomb. So this velocity of plane was given to you. The height of the plane from ground was given to you. When I was throwing a projectile from a tower, the height of the tower was given to you. When I was throwing a projectile from ground, the initial velocity and the angle was given to you. There are some terms that always come in a particular type of question. What type of terms do we see in a river flow wale questions? The first term is known as this one, VMR. VMR. Now we are mature enough to understand what will be the meaning of VMR. Can anyone tell me what will be the meaning of VMR? You don't know anything about river flow right now. No, nothing. What would be the meaning of VMR? M standing for man, R standing for river. Now instead of this as VMR, instead of this being man, it can also become a boat. Instead of this being a river, it can also become water. So it could be velocity of M with respect, velocity of MW, velocity of MR, velocity of BR, velocity of BW. Let us take the example of VMR. What would VMR mean? Anyone? What would VMR mean? It would mean velocity of man with respect to river. Instead of a man, this could be a boat. So this will become VBR, velocity of boat with respect to river. Instead of calling it as river, I can call it water. Velocity of man with respect to water and velocity of boat with respect to water. Do we understand this? Can I have some reason that we understand this? So in question, this term will be given in this way. Either it will be given directly, velocity of man in river, velocity of man with respect to river, or it will be written in this fashion. If a man can swim relative to river with a velocity VMR, let me just magnify it for you. I hope you know that while you are in class, you can also pinch and zoom. Make it bigger, pinch and zoom. So how this VMR is going to be given to you? It may be given straight away. Velocity of boat with respect to river is this much. Or the boat can move in the river with this speed. Or the man can swim in still water relative to still water with this speed. Everything means it is velocity of man with respect to river. Am I clear? Am I clear? Can I have some reason that we are clear with this, sir? Tarun understands this. What about the others? Abhinam Niharika understood this. Srilata, she never talks. Bhojraju, I don't know what he does in the class, never talks. Tanu, Nayan, Vishal, Akshay, same case. Never talk. Anyways, one day you might. That is the first time that must be given. Oh, I got someone else to talk. Who was he? Okay, Tanu. If a man can swim relative to water, so that is VMR. The other thing that will given, water is flowing relative to ground with a velocity VR, we call it VRG. So what is VRG? Velocity of river or water with respect to ground. Do we understand this term, velocity of river with respect to ground? Have you heard this term? Velocity of boat with respect, velocity of car with respect to ground, boy with respect to ground, tree with respect to ground. So we already know this term. What is the third term that is going to come here? The third term is velocity of man with respect to ground. So we call it as VMG. But remember, the man or the boat is in water. He's swimming in water. So in almost all the cases, this velocity will be unknown because we won't be able to, in the question, this velocity will not be given. Whatever velocity of man is given in the question will be the velocity of man with respect to river. It can be given in different ways. But you always remember these golden words that I am speaking right now. Please listen to me very carefully. In all the cases, almost all the cases, 99.9999% of cases, velocity of man with respect to river will be given to you. Velocity of river with respect to ground will be given to you. And you will be supposed to find out velocity of man with respect to ground. Am I clear with this? Can I have some raised hands? Now, how are these three velocities related to each other? How are these three velocities related to each other? We already know the answer. Who is going to tell me what is the relation between the three velocities? Who will tell me what is the relation between the three velocities? Velocity of, anyone can tell me? The relation between the three velocities that I am talking here. Velocity of man with respect to river will be equal to velocity of man with respect to ground minus velocity of river with respect to ground. Do we know this equation or is this something new? Do we know this equation or is this something new? Known. Now I can write this equation in a different way now. Because here I know this velocity. I have to find this one. So I will take here and bring it here. So now the equation looks like this. Velocity of man with respect to ground is equal to velocity of man with respect to river plus velocity of river with respect to ground. Do we all understand this? I've written the same equation in a different way. Yes or no? Yes or no? When I have some raised hand that we understand this, sir. Same equation written in a different form. In fact, if you remember, velocity of m with respect to r, when I wrote it, vector form, remember that topic, vector addition, I put a, should erase it first, eraser. When I had to find out the velocity of man with respect to ground, what I do is I put river in between. And then I write it like this. It will be velocity of man with respect to river plus velocity of river with respect to ground. This r and this r cancel. Do we remember this addition of vectors? So I've just used the same phenomena here. And using this phenomena, velocity of man with respect to ground is velocity of man with respect to river plus velocity of river with respect to ground. We will be solving problems based on relative motion in river from the next class. I'll wind up today's class here on this note. Given you homework of that problem of bird, old man, and boy. Solve that problem, put it in the group, and we'll be doing some very interesting problem in tomorrow's class. Don't miss it for anything in this universe. We're doing some great problems, and we'll be winding up this chapter very soon with this and after this. So I call this a class today. The class stands dismissed at this point. We'll meet tomorrow. I hope God will keep you safe, healthy, and I'll see you happy coming for the class tomorrow. From now, it's a bye-bye. It's a wrap from my end. See you tomorrow in today's class, in tomorrow's class. Have a nice day, beta. Take care. Bye-bye.